All right, guys, let's do a few problems off the 10.7 worksheet. Okay, so this section was dealing with the areas of circles and sectors of circles, and this first batch of problems is pretty straightforward, just asking you to find the area of each. So I hope you guys are catching on right now. Three-step process. Step number one, we start off with the formula here for area of a circle, which is going to be pi multiplied by the radius of that circle squared. Step two, let's fill in what we know. We're trying to find area, and that's equal to pi times your radius, which is right here. That's 2 inches. And I'm going to go ahead and include the units right here in case you didn't see this explanation before, and we're going to square that. The cool thing about circles, guys, is that they only have one measurement, radius. So that was the only piece of information that we needed, so we're ready to go ahead now and complete the right side. Now, honestly, I'd be a little disappointed if you guys were grabbing a calculator in order to do this. You've got to take 2 and square it. 2 times itself is going to be 4, and then just stick the pi on the end right there, and you're going to get 4 pi. I wanted to talk for just a second about units right here. Our radius was measured in inches, but those inches are going to get squared. And just like you learned with a variable in Algebra 1, when you square a unit, you end up with the square version of that unit. So inches squared is going to get you square inches. And again, even though we write it as inches and then the exponent of 2 after that, you don't say inches squared. You're going to read that as 4 pi square inches. Okay, 2, 3, and 4 are pretty similar. Be careful because I think on 3 and 4 they gave you the diameter. You need to know the radius in order to do that. So if they gave you the diameter, you're just going to cut that in half and use that smaller number for your radius. All right, let's jump to actually number 4. I think I got ahead of myself. I think this is the problem I was just talking about. The directions are the same here. They're still asking you to find the area of the circle, and there's only one formula we have for area of a circle, everybody. It's pi times your radius squared. So, as I was just saying, we need to know the radius of that circle. Well, in this problem, they gave you 14, which was your diameter. That's going to be 14 meters. So the radius is always found by taking your diameter and just cutting it in half or dividing it by 2, so that radius is going to be 7. So this is pi times a radius of 7 meters. That's going to get squared here. And that's pretty much it, guys. Step 3, the area of our circle now is going to be 7 squared is 49. The pi just goes along for the ride. And meters squared are going to get us square meters for the answer there. So 49 pi. Again, maybe when you did a problem like this in middle school math, they told you to grab your calculator and multiply by 3.14 to get that as a decimal. That rounded answer, in fact, let me do that for you real quick. If I typed 49 pi into my calculator, I get 153.94. That would be an approximate answer. 153.94 square meters right there, which might be more useful out there in the real world, but what we're interested in at this level is trying to come up with exact answers, so that's why we prefer to leave them in terms of pi. Okay, 5 and 6 I think are similar problems. Now number 7, you've seen a lot of these problems this chapter. This is where they reverse things on you. Okay, they've given you the area of the circle now, and they're asking you to come up with the radius. So for step 1, and this is where that 3-step process becomes really important, guys, and we get to see how disciplined you can be as you're going through this. You're looking for a formula that relates the thing you know and the thing you're trying to find. A formula that relates area of a circle with radius of a circle. Well, that's the exact same formula we've been using here. Area of a circle is equal to pi times radius squared. So you always want to start with that formula. Step 2, you fill in what you know. And now what's unusual, we know the area of this circle. We know that this left side, the area, is going to be 16 pi, is equal to pi, and we've got a radius here, which we do not know. That's what we're trying to find, and that's going to get squared. So this is kind of a reversal of what we were doing earlier, where we knew the radius and we were trying to find the area. Now we're going the opposite direction. We know the area and we're trying to find the radius. So now this really becomes an algebra problem. We've got to try to get r all by itself. So you want to ask yourself, what is being done to my variable and how do I undo that? Well, as we look at the r right here, 2 things are happening to it. It's being squared and it's being multiplied by pi. So by order of operations, exponents take precedence over multiplication. But when we're undoing things, that actually means that we have to get rid of the multiplication first. We kind of reverse our order. So to undo multiplication by pi, we're going to divide both sides of this equation by pi. And this is another spot here, guys, where you shouldn't need your calculator. Identical factors on both the top and the bottom are going to cancel out. And the same thing happens on the right with pi divided by pi. Those are just gone. So now as we kind of transition into step 3 here, we're at a 16 is equal to, and the pi's are gone, so now you just get an r squared. And the last thing we have to undo now is the square, which we do with a square root on the right, and we balance that with a square root on the left. The square and the square root cancel, and that leaves us with r is equal to, and we got lucky here, 16 is a perfect square, our radius is equal to 4. Since the units for area were square centimeters, technically this was 16 square centimeters right there, and the square root of square centimeters is just going to get you plane centimeters, or what we call linear centimeters in the biz. All right, and that's how you come up with the radius of this particular problem when you were given the area. If they asked you to find the diameter, which I think happens on a subsequent problem here, you would do all the same work that we just did. You would find your radius, and then you would just double that answer. So here, if they asked me for diameter, my radius is still 4. My diameter would always be twice that answer. 4 times 2 would be 8 centimeters if they were asking for that information. And last one here that I'm going to do with you, number 9 here. Find the area of a sector. Okay, so this is a formula that was in your notes here in section 10.7. And the formula for area of a sector works off the formula for area of the entire circle, which is pi times radius squared. But once again, just like we did with arc length in 10.6, we don't want the area of the entire circle. We just want the area of part of it. And the part of the circle that we want is measured by our central angle, or by the degree measure of the arc in question. And the whole circle is still always going to be 360 degrees. So that's the formula right there for area of a sector. Theta over 360 times pi r squared. Step 2, let's fill in what we know. We are trying to find the area of the sector. We don't know that yet. So area equals theta. The degree measure of this arc is the same as the degree measure of our central angle here, which is 90 over 360, and we're going to multiply that times pi times a radius they've shown us here of 16, and that's going to get squared. Now, in terms of what this is going to look like to simplify, again, I'm going to leave my answer exact. So the pi right here is not going to get put into my calculator, but everything else is, and let me show you what that is going to look like here. So we started off with a fraction of 90 over 360. So let me do 90 over 360, and then I'll get out of that fraction. And then we're going to multiply that by our radius, which was 16, and that 16 is going to get squared. And that got us an answer of 64. So I'm going to write that down. So the 90 over 360 times 16 squared is going to be 64, and the pi that we didn't type in just tags along on the answer here as kind of a trailing factor there, so 64 pi. Since the radius was given to us in yards, and then we squared that yards, we're going to end up with square yards for the units on our answer. So 64 pi square yards is the area just of this slice of pizza right there, that sector. All right, guys, give the rest of that a try. Let me know if you guys have any questions, and good luck.